This is how cold it is in Canada.
No, it's not. You live in Toronto, and this is what the weather looked like when you recorded this video. I'll be kind and take the lowest temperature, which is 21 Fahrenheit or negative 6 degrees Celsius. I found the same kettle. It has a triangular spout, and the cross-section area of it would be 0.5 times the height of the triangle times the bottom side, which will be 1.5 centimeters square. The speed of the water as you're pouring it is 1 meters per second. Multiply that by the area, and we get the volume flow rate to be 150 centimeters cubed per second. Then we multiply this by the density of water at 1,000 kilograms per meters cubed, and we get the mass flow rate, which is the mass of water leaving the kettle every second. For the water to turn into ice, we need to remove two components of heat from it. One for cooling the water from 100 to 0 Celsius, and another for changing the phase of the liquid from water to ice. The amount of heat we need to remove to get from 100 to 0 can be calculated by multiplying the specific heat of water by the difference in temperature, which will be 420 joules per gram. For phase changing, we need the latent heat of fusion, which is 334 joules per gram, which means in total we need 754. Multiply this by the mass flow rate we calculated, and this means we need a continuous 113 kilowatts to freeze that small stream of water. Now this is the formula I'm using to see how much cooling the air of the rooftop of your apartment was providing. H is the heat transfer coefficient, and I'll be kind and assume it's 100 watts per meter squared Kelvin. A is the surface area of the water, which is 314 centimeters squared, and delta T is the temperature difference, which is 106 Celsius. The simple math here shows that convection can only remove 0.3 kilowatts every second, but you need 113 kilowatts for the water to turn into ice, which is 340 times bigger, which means your video is not real. That was a fun way of doing it, but if you look at this frame, I don't understand why some of the water decided to freeze and some of it is just falling to the ground.